of inspiration from my good colleague Anu Hopia at the University of Turku, and she's a food scientist. So I'll be starting now and talk about a few challenges in science education. From a paper by Gilbert and colleagues, they give us some challenge in science education, and also these challenges I feel that I can see also in with my own eyes when I visit schools, etc. And one of the things about science education is that most of the science education we give in Scandinavia and maybe most of the world for compulsory school is science education for all, not for only for those who are going to be chemists or physicists or whatever. So this is a fact that we have to take seriously, that those who are our students, most of them will not be doing science careers, but still they're going to learn science. Also, we see that many students feel that this science teaching that they're getting, at least sometimes, is felt to be irrelevant, or they ask these questions, why do I have to learn this, etc. And we see that much of the motivation for students is usually to pass the exam rather than to learn about science. There is another challenge is that students feel that it is difficult for them to take the knowledge and transfer it to the everyday life. This is called transfer of learning, and usually we see that the transfer of what they learn, for instance, in science class to everyday does not occur very often. They learn something in science class and they are able to maybe answer those questions correctly in the exams or in the tests, but the relevance to their everyday lives is often quite limited. So my main interest in this area of science education is, can the context that we teach science make a difference? If we look at the contents of science, we see that, of course, there are lots of facts in science. We need to learn about chemical nomenclature, we need to learn about pH, organic functional groups, etc. So this is an important part of science education and science teaching. But science is also ways of doing things and ways of thinking. And this part is actually not that easy to teach, and it's not that easy to promote in science education, at least what we see from Norway. We see that teachers are fairly good at teaching this part, but they are struggling with teaching about this part, because this you can learn and you can then answer a question about some factual things, but this has to do with a way of thinking, which is actually apparently more difficult to teach for many teachers. So my research interest then is to teach, and hopefully the students learn about the scientific methods and the ways of thinking, in addition to what's been called declarative knowledge, or the facts. And hopefully in a way so that the students can learn something that could be useful for them, either right now or sometime in the future, even though they're not going to maybe have further education or have a career in science. And the context that I'm mostly interested in is in food. It could be other contexts, of course. I've chosen my context food because I'm really interested in food. And one thing about the context food is that everybody eats every day, at least in our Western world. So this is something that has to do with every person. You can't say that you're not eating, that this food doesn't have anything to do with you. And also, very often when we eat, we make judgments. For instance, we could say that we like it or we don't like it, or we make some evaluation, or we talk about what we're eating, or we're thinking about what we're eating. So maybe we could use this as a possible context in science education. And then we could ask, can we then, if we are able to use this context in science education, which is also something that our students will meet every day, how would it be possible for them to transfer this to their own lives? And that could possibly be beneficial to give new experiences. It could affect what you choose to eat, if you eat more or less vegetables, things like that. And also maybe be more accepting towards other types of food and things that you haven't tasted before. And what I'm going to talk about today is more of a method and way of thinking. And if you have any opinions, thoughts about this, I invite you to give them, because this is not, I'm not giving you the one right answer for how to do science education, but I want to come up with some ideas, some thoughts, and we are playing around with this, how to use this in science education. And I found some inspiration from what's called sensory evaluation techniques. And of course, those who are familiar with these techniques, they would say that this is nothing new. This is old news. People have been using these techniques for decades, or maybe a century or two. But when I met these techniques the first time a few years ago, I immediately felt that this has a great potential in education, in science education, and in home economics education, for instance, and maybe also in other school subjects, and not the least for the transfer of knowledge from school to everyday life. So what I would say is, when you taste something, don't say if you like it or not. And if you serve food to someone, don't ask them, did you like it? Did you not like it? Or so sort of don't promote judgment of like or dislike. But rather than doing that, ask for analytical or descriptive evaluations. Or if you sit and eat yourself, if you sit at a cafe, you get a dish served, then before saying you like it or not like it, or think about this, start thinking, how does this taste? What sort of degree of sweetness do you feel? Saltiness, sourness? Can you describe how it smells? Our sense of smell does not have sort of basic smells, so that's why we have to make associations with other things that we have been smelling, like those people who are testing wines. They would say have associations to different kinds of berries and tobacco, etc. That is because we don't have basic smells, so we need to associate. Also textures. So rather than doing this, go towards this. And this is also something to do when we are with our students. And it might also perhaps be possible to transfer this to other situations than eating. Promote a different way of thinking. And then we are actually moving, in some sense, towards a scientific way of thinking. And then, when you have done all this, then you can conclude I like it or I don't like it, but not in the beginning, but in the end. And this you can do at a hamburger bar, you could do it at home, around the dinner table, you could do it in school, etc. I'll try to give a few examples. And I'll give you a couple of, first I'll give you a couple of methods now to do sensory evaluation, really basic things. And then I'll give you one example at least from chemistry education. Because if you have, previous slide I showed talked about how you would, or you could evaluate something that you are being served or something that you're eating. But if you have two different things to compare, actually going towards a scientific way of thinking is even easier. For instance, you could compare two different versions of one product or two different products. If you are in school at lower secondary or primary school and you're making food in home economics, maybe two groups of students have made the same dish, then you can do a comparison between those two. And then we have two different things that we could study. Either if they are really similar, if the two groups have made the same thing, if two groups have made one porridge each, then we can ask, is there a difference? Yes or no? And then there are some techniques to make set up an experiment to decide if they are different or not. There is sort of a blind experiment. And then the next question we could ask then is, if they are different, how or in what ways are they different? And I will also give some examples of how to deal with that. For the first example, if we have two products that are almost the same, or we are not sure if they are the same or not. That is, we have two almost identical samples, or they might be identical. Then we can set up a triangle test. So now comes the first practical tool for you to use in some situation. And this is a type of a blind test. Here I have made a drawing of two students or student groups. Let's say that they have made the same tomato sauce at school. Then we have sample 1 from this group and we have a sample 2 from this group. What we do then is we take 3 bowls and we take, for instance, sample 1 in one of the bowls and sample 2 in 2 other bowls, the 2 other. So now we have one triangle with first sample in 1 and the other sample in 2. And the one that is alone, we make a mark underneath. We shouldn't see the mark, but it could be a cup, and we have a small piece of tape or something. And then we could make one triangle like that, or we could make more triangles. We could make 2 triangles, 3, 4, or 5. What we then can do is we do like you see in the streets when the guys are having this ball underneath the cup. You change them around. So now no one knows which is number 1. Now I've just indicated that there, but that would be invisible, and which of the 2 others are identical. So what you can do then, you have 3 samples. You know that 2 are identical, 1 is different, and you don't know which is which. So you taste all 3, and if you can, and then you have to choose one. which you think is the one, and leave the two others. So you take the one and move it forward. So you have made a choice. It's a blind choice. If you are able to choose the right one for several times after each other, then the experiment would show that, okay, you are able to notice a difference. So there is a difference. But if you are not able to do that all the time, but one time you choose the right one, the other time you choose the wrong one, then it could actually be that you're not able to notice a difference. For instance, let's say that this first group, they say that ours are better than this group. And the others say, oh, it's not possible to notice a difference. Then you could set up a triangle test. That's one example of this. So then we have one experiment to demonstrate, is there a difference, yes or no? And there are some really good descriptions of this on in a couple of web pages. I will show you the links later. The other example is, then if you have decided there is a difference, or if you already know there is a difference between two products, then we could set up some quite systematic experiment to decide what is the difference. Then you can have two samples, and a good method then is to have sample A and B, do a blind sample, and then choose which is most or least. So you are doing a ranking. For instance, which of them is most acidic? Is A most acidic or B most acidic? Or you can do sweetness, you can do bitterness, saltiness, or texture, or aroma, which does smell most of tomato, if there is a tomato sauce, etc. So you have sort of ranking. Then, if you have a full class, you can actually make a count. So let's say that you have this tomato sauce and ask which is most sour of these two, or acidic. And then you would have all the students taste, and some would say A, some would say B maybe, and then you have a distribution of 2 says B is most sour, and 8 says that A is most sour. And suddenly, what has happened then is that you have quantified sourness in these two in a way. For instance, let's say that we have two orange juices. Then we can mark them A and B. We can fill them in some glasses, and then we hide them. And of course, there should be someone who is putting the marks A and B who are not part of the experiment, so that no one knows what is A and B. And then comes this thing that is the star diagram, which is quite standard for many people, but which again helps us to measure taste in a way. You can then set up such a diagram. Then you can decide together with the students, what are we going to test? Sweetness, sourness, aroma maybe, which has most aroma, which has the strongest orange flavor if we are comparing juices, which is most full-bodied, which feels most watery. And notice that all these are quite, they're not entirely subjective. They're not, of course, they're not objective, 100% objective, but they are more objective than I like it or I don't like it, or I like A more than B. But then as the last one, you could say, okay, which one do you like most? And then if you have 10 students, they would then rank A sweetest or B sweetest, which is sour, which has most aroma, etc. And then you can plot that in this diagram. And for instance, this could be your result. B is the blue line, A is the red line. And in this case, this is just make-believe. I just made up these numbers. We see that, oh, they are approximately the same sweetness and sourness, but the students say that B has more aroma, it has a stronger orange flavor, and it's more full-bodied. Whereas they say that A feels more watery. And they also then say that they prefer B. So that could maybe say something about that they prefer the juice with more full body and aroma and orange flavor. And what you have done now is you have, in a way, quantified taste, and you have moved from saying I like or I don't like to something that is, in a way, a bit more scientific thinking. So this is the two examples I wanted to show you very quick. Now the final slides. I would say there are a few possible benefits from this that could be. I can't guarantee, but I think this is thinking, at least, that could be included maybe in other activities as well. I would say that it's definitely a way of promoting analytical and a bit more scientific way of thinking. And it goes straight into everyday life. So you could ask your students, go home and evaluate whatever they are eating according to some criterion. Or they could even challenge their families to do such a analysis around the dinner table or whatever. I think it might promote openness for new tastes, because you don't judge it right away. You have to try to understand what you're tasting before you're actually saying that I don't like it or I like it. You have to describe it. And you can actually include some mathematics and statistics in this as well. I could show you later, if you're interested, in the triangle test, that there is some simple statistics coming straight out of that one. And hopefully you can also use it in other ways of experiments. For instance, using cosmetics, you can do analysis of perfumes, for instance, and actually that can be used. For instance, I just came to my mind now, if someone says, I don't like your perfume, then you could actually split up the perfume aroma into different components. Then you could maybe find out what is it that you don't like. And if you don't like broccoli, if your children don't like broccoli, if you split it up, oh, is it the taste? Is it the texture? Is it the color? Is it the aftertaste? Things like that. And then maybe actually you could cook the broccoli so they like it. And not the least, if you make an experiment out of it once in a while, not every day, that will be really tiresome, but once in a while, you could actually make your children or your students or whoever taste a small piece of broccoli. And if you do that tasting a few times, you might start to actually start accepting the taste of broccoli. I will take the question from Katarina afterwards. Just one experiment from chemistry. Maybe some of you know this experiment called Mustica Trio, blueberry trio. This is an experiment that you use the colors from blueberries as pH indicators. And you can find this on the Luma pages. And what you use then is the three colors showing that this is the most acidic layer, this is probably the least acidic layer, almost over to basic, and this might be somewhere in between, for instance. That's by color, but actually maybe you could also extend this to the tasting, because when I do this experiment, usually we do the experiment, then we assess the colors, and then when we're finished doing that, the students just eat it and enjoy it. It's of course good, but it's you just eat it. But if you then include evaluation in the eating part as well, you could then reflect on which part of it does taste most acidic, and then at least you could start reflecting, although you might not get the one correct answer. Okay, so there are some links, a really good web page from the British Nutrition Foundation with lots of resources, copy papers, copy sheets and everything, giving also a teacher's booklet. Everything is downloadable from the web. This web page by Jeff Walker gives quite nice and straightforward explanations of various sensory analysis methods. The Blueberry Trio or Mustika Trio, which is in now both in Finnish and in Norwegian. And finally, there is a new book by Maija Tuomisto and Anu Hopia and Maja Aksela from here in Helsinki about food in chemistry and home economics. And maybe then you could actually do these experiments in this book. It's an ebook, and you could also incorporate tasting methods in this. Okay, so I have just a few more slides if there are questions about that, but I've now spent almost half an hour, so I think this is enough talking from my part. So I can take some questions or comments if you agree or disagree or whatever. Katarina, she writes that it's a good way to make students think scientifically. The next step is asking or thinking about why they taste differently. And that is usually a very complex question. And that is maybe the major challenge using food and everyday things in chemistry education and science education, because reality is complex. And perhaps that is also the reason that many of the chemistry experiments we have at school are very simple. If you want to do an experiment with precipitation reactions, that is fällingsreaktioner. You mix silver nitrate and sodium chloride solutions and you get the white precipitate. But it's a very chemically very simple, but no one would ever use that in their everyday life. So we have this dilemma. If you're using things from everyday life, they are usually quite complicated. If you want to do simple chemistry that is easy to understand from the chemistry point, it might be that it's distance from the everyday life. And that is one of my projects, to try to find those examples where everyday life and the chemistry come together. Yeah. Mia, a very good point about the uncertainty, or that there is a spread in results. And usually when you're doing taste, you would not get 100% this way or 100% that way. And these experiments, then, I think I agree with Mia that they really illustrate very well that usually scientific results are not 100% in one direction, but we have to we have to deal with it and then discuss, is this a significant result? Of course, then you could use statistics and things like that, but even at primary school, if you say that it's eight students this way and 2 students that way, we would say, okay, this is quite convincing. And it might not be wrong to be those 2, because we are born differently, or we have different preferences and things like that. So this is quite normal from sensory evaluation as well, that you get a spread like this. So I invite more questions. Feel free to write. Or if you feel that something is unclear, I could try to explain or something. I noticed that I didn't start the recording right away, so I just have to repeat that this is a lecture, which is a part of the Chemistry Education Center webinar series at CHEMA. And we're now the 12th of November, 2014. Yeah. Any more questions? I have a few more slides, but yeah, there is one from Mikko. I think this is a matter of fantasy. But what you could do is you could, for instance, go into Google and you could write star diagram. A star diagram is this one. And then you could actually see where do they use star diagrams. And you could actually, this could of course be used also in other situations, but for instance in cosmetics they're using this when you are characterizing something in more than one dimension. And I see that these star diagrams are not much used in school, and that might be the reason that me not being educated in specifically in these sensory sciences, that this is, I saw this sort of as an adult and not as a child, but they are quite visual, and I think they might actually be a good way of really quickly get a picture of something. And this would also, of course, be part of how to incorporate mathematical thinking. Just to set up a diagram is a mathematical skill. Material education. Thank you, Yanni. Thank you so much, Umalkar. I hope so, and we try to post these things on internet, and we are very happy to get feedback on things that come to on Luma, and also this web page. If you read Swedish, you would be able to read Norwegian, and Norwegian also translates fairly well using Google Translate. Something that's Finnish does not. So, and this is now science.no/food. So there are quite a lot of things there as well. I'll just finish off with a few slides while I think there are some questions coming. So a few more tips. These triangle tests I showed you, these are actually being used in coffee tasting competitions in the World Championships and the National Championships, etc. And if you go to, you could either do a Google search or a YouTube search for cup tasting championship, or you could go to This specific video, there you see how they are using, at least it's very similar to triangle test, the triangle test, to compete about who is the best coffee taster. And it's about being able to notice the difference between two coffees, for instance, two coffees from Guatemala but from different farms or whatever. It's quite fun to look at, actually. Also, if you want to include some statistics and mathematics for the triangle test, it's a good way of it's a good possibility to work interdisciplinary between scientific ways of thinking, and if you like to include home economics, that's called mat og helse in Norwegian, and hem- og konsumentkunnskap in Swedish. Then actually you have something that could work in all three subjects, because if you were picking the one just by chance, by closing your eyes and picking one, there would be a 33% chance of picking the right one. But if you do more than one triangle, getting both right would be 1/3 times 1/3. And usually, I think it's said that you would need 5 triangles to get a fairly statistically significant result. Because then, at least if you get all 5 right, you have then, there is a very small chance that you did it by sheer luck. Because the chance of choosing all the 5 after each other, the right, is very small. And this you can have one triangle and have different people taste it, and you change between each person, or you could have several triangles and then have the same person doing several triangles. Krista, better learning results. I would say I can't guarantee that. I have to be honest, and we're discussing this quite a lot actually with our students as well. Does inquiry teaching, for instance, does that lead to better results? I think it's maybe it's typical university person answer, but let me try. Both the Norwegian and the Finnish curricula are very specific in saying that the chemistry, for instance, that you learn should be linked to everyday life. So the curriculum asks us to do it, actually. Even though it might not make, if I change my teaching now, today, from today to tomorrow, but I continue giving the same tests for the students and giving the same exams, I think that would be quite, it might not actually give better results, because our system is really sort of is made so that we are going towards the exam. And I think then the result of that is that it might be more difficult for teachers in upper secondary, in high school, and in the last years of lower secondary, where the exam pressure is really hard, to do things like this, because the consequences they're fair for the consequences. But I think maybe I wouldn't say that we are on the wrong track now, but I would say that there might be a gap between, at least when I see the textbooks for chemistry education, there is a gap between how the textbook describes chemistry and what the curriculum asks us to teach. Because the curriculum always says, link this to everyday life, link this to your own life, whereas the chemistry textbooks focuses on organic chemistry and learn all the functional groups by heart, and then be able to write all the functional groups in the exam. So maybe there is a mismatch there between curriculum and textbooks, at least. Yes, so maybe a typical university answer, but still. Yes, Janni. In Norway, I teach both chemistry for teacher students, that is pre-service teacher students, and I also teach home economics. So what I do then is when I go to the home economics students, I try to promote science for them to have a scientific way of thinking when they are cooking and when they are reading about food and learning about food. Whereas when I'm teaching science, at least once in a while, I try to include food or everyday life examples. So sort of depending on who I'm talking to, I'm promoting the other part. The students that I teach in Norway would generally teach in primary and lower secondary. That is, in Norway we have 10 years of compulsory school before high school. So that's generally most of our students will go into that part of the school. So yeah, and I think actually it might be easier in home economics than in science, because the pressure of the exam is not that high, and although it might be, some might feel it's unfortunate, we don't have home economics in Norwegian high schools, and you don't have it in Finland either. So then there is, you don't have this pressure that they should have learned all this before they come to high school. So I think there is more leeway, there is more flexibility in home economics teaching than it is in science teaching, maybe. And I think I would say shouldn't look specifically to Norway on this, because Mayu, Anu, and Maya, they are doing a great job here as well, and that's one of the reasons I came here, actually, to cooperate with these great people here in Helsinki. I'm teaching here in Helsinki now about inquiry, and we are doing some. We are including some of this molecular gastronomy in that, and I will probably be teaching now this winter also after New Year. So there will be one course, I think, in the chemistry of everyday life, and there will also be another course on inquiry. So there will be, I will probably be involved in some of these until, well, I'm staying here until June this year, next year, in 2015. Thank you for the support. It's nice to get positive feedback as well, but I'm still missing some critical comments. Do you have any? And I don't have any more slides for you. So if you have more questions or comments, just fire away. And if not, you can log off at your own wish. And I will be sitting here a few minutes more until I see that people have logged off. Yes, Janni, I think also that this is a good candidate to combine home economics and chemistry, and that I think that's the reason that I've also been sort of started working more with this, because I find that there are some really good possibilities, and the closeness of chemistry and also physics and biology with food is really good, and it helps. It's a very good context, actually. Thank you for coming, Krista, and thank you all for attending. This lecture will be recorded, and at least, well, we might have missed a couple of minutes, the first couple of minutes, but it will be recorded and it will be posted, I think, at the CAMA website. Okay, so last question. Janni, no, actually my PhD is in organometallic chemistry. So I have a doctorate from University of Oslo in more or less pure chemistry, or in the intersection between organic and inorganic chemistry. After doing that, or at least in the end of that, I went to Volda University College and started working there. And for maybe 12 years now, I've been involved with food from after my doctorate, actually. And I've been collaborating with people and have had many good discussions with colleagues who are into food chemistry, and I've been reading lots. So that has been my entry into both education and into food. Okay, so thank you for showing up, everyone. And there is one more question. If there is one more, I will. Yeah, thank you so much, and welcome to the next session. You will find the